Have you heard about this DeepGMM? It's gotten crazy fast.
Yeah.
Like exceeding 1350 TFLPS on NVIDIA Hopper GPUs fast.
Yeah, and using FP8 precision, too. It's pretty remarkable.
Yeah, so that's what I was curious about. DeepGM, what is that all about?
Well, it's a high-performance FP8 GMM library,
Okay.
and it was recently open-sourced by DeepSeek-AI.
Interesting.
Yeah.
So FP8, I mean, how does that play into this? And what's GMM stand for in the first place?
Yeah, so GMM stands for General Matrix Multiplication, and it's like a core operation in a lot of AI computations, especially in deep learning.
Gotcha.
So you're probably familiar with deep learning. And then FP8 stands for Floating Point 8.
Okay.
And it's a numerical format that uses less memory and less computational power than traditional formats like FP16 or FP32.
Oh, so it's like a trade-off. We lose a bit of precision, but gain a whole lot of speed.
Exactly.
Makes sense.
And it's a trade-off that makes sense in a lot of these AI applications where speed is critical.
Gotcha.
And you know what's really cool is that DeepGM achieves this speed with a surprisingly small code base.
Oh, really?
Yeah, only about 300 lines of code for the core kernel.
Wow. 300 lines of code. So someone could actually go in and like kind of figure out how they're doing this.
Absolutely, yeah. The DeepSeek-AI team really prioritized clarity and simplicity when they designed it,
Cool.
which makes it not just powerful, but a really good learning tool.
That's fantastic.
Yeah.
So you mentioned earlier this JIT compilation, which I think stands for just-in-time compilation.
Right.
So how does that factor into all of this?
Yeah, so JT compilation basically eliminates the need for pre-compilation.
Okay.
So DeepGM can adapt on the fly to different GMM shapes and parameters to ensure optimal performance in a lot of different situations.
So it's kind of like it adjusts itself as it goes.
Exactly, yeah. It's constantly optimizing and adapting.
Very cool. So what are some of the techniques they're using? I mean, to actually get these results, it sounds almost magical.
Yeah, well, one of the key techniques is called fine-grained scaling, and this helps them maximize the use of the FP8 dynamic range,
Okay.
which essentially means they're fine-tuning these calculations to squeeze out every ounce of efficiency they can from the FP8 format.
Interesting. So what else are they doing?
Another technique they use is called two-level accumulation with CUA cores.
Okay.
And this addresses some of the potential accuracy limitations that come with using FP8 tensor cores.
Gotcha.
So they're able to ensure accurate results even though they're using a reduced precision format.
Very clever. There's this other thing I saw, persistent warp specialization. What is that?
Yeah, so that one's actually inspired by the CDS library.
Okay.
It basically specializes these warps, which are units of execution on the GPU.
Gotcha.
And by specializing them, they can make sure the computational flow is really streamlined and efficient.
That makes sense. So they're kind of taking inspiration from these other libraries like seek-ls, and I think as a compute also mentioned. So how similar is this to those? Or is it kind of its own thing?
I mean, it definitely takes inspiration from those other libraries, but their approach with DeepGMM is unique.
Okay.
What sets it apart is that they really focused on being user-friendly and simple to use.
Nice.
So they avoided using complex templates or algebraic libraries to make it more accessible to more developers.
I like that approach. Well, we actually have some data here that kind of breaks down some of the speedups that they're getting with DeepGEMM across various GM shapes.
Oh, cool.
So this includes like the ones that are used in both dense and MOE
Right.
models.
Right.
So let's start with what they call normal GEMs, which are used in like those dense models.
Okay.
What kind of speedups are they seeing there?
They're seeing some pretty good improvement across the board. So, for example, with a GMM shape of 6.4 by 21, 12 by 7.1, and 68, they're seeing a 2.7x speedup.
Wow.
Which is pretty significant.
Yeah.
For a larger one, like 4-year 9.6 by 7.168 by 20 or 48, they're getting like a 1.1x speed up.
Okay.
So maybe not quite as dramatic, but still pretty good when you consider how large those matrices are.
Yeah. It's still a noticeable improvement.
Yeah.
Okay, so that's with those dense models. So what about grouped GEMs, which are used in those MOE models?
Right.
What do those numbers look like? Let's start with the ones with a contiguous layout.
Okay, so for those, let's look at an example with 4 groups.
Right.
And a GMM shape of 8192 by 4096 by 7168 per group.
Okay.
They're seeing a 1.2x speed up.
So even in that MOE scenario, they're still getting some good performance gains.
Yeah, definitely.
What about those with the masked layout?
For those, let's say a single group
Okay.
with a shape of 1024 by 4096 by 7168 per group, they're getting around a 1.2x speed up there too.
Okay, so pretty similar, whether it's contiguous or masked.
Yeah, pretty much.
Wow. So DeepGEMM is looking really impressive. They're getting these speed ups across a pretty wide range of GMM shapes.
It seems like they've really pushed the boundaries here.
Yeah. I'm sure our listeners probably eager to learn more about what this all means, like what kind of impact could this have?
Yeah, definitely. It's not just about raw speed either. Like, there's the potential for this to really open up AI development to a lot more people.
Oh, interesting. So we should probably dive into that a little bit more next time.
Absolutely.
Sounds good.
Yeah, so I mean, by like simplifying these complex computations and making them way more efficient, DeepGM could really allow a ton more researchers and developers to experiment with larger and more sophisticated models.
Right. So even people who don't have access to these huge computing resources, they
Exactly.
can still kind of get in on the game.
Yeah, it really levels the playing field and I think could lead to a surge in innovation
Interesting.
as more people are empowered to just kind of push those boundaries of AI.
Yeah, that makes sense. And it's not even just about the research and development side of things, right?
Right.
Like this kind of efficiency, I mean, it could have ripple effects on real-world applications
Oh, absolutely.
across tons of different industries.
Yeah, think about like natural language processing, computer vision, or even like personalized medicine. Deep GMM could lead to things like faster diagnoses,
Right.
more sophisticated chatbots, and self-driving cars that can react much more quickly to their surroundings.
It's really amazing to think about all the different possibilities.
Yeah.
You know, we were talking about how the creators of DeepGEMM drew inspiration from some other libraries like C-TLS and Qt,
Right.
but it's not like they really put a strong emphasis on simplicity and usability.
Yeah, they did, and that was a conscious choice. It really reflects DeepSeek-AI's commitment to making this kind of advanced AI technology more accessible. So DeepGEMM becomes a really powerful tool, not just for seasoned experts, but also for people who are relatively new to AI.
It's almost like a high-performance sports car that anyone can learn to drive.
That's a great analogy.
Yeah, I like that.
Yeah, and then, them open sourcing DeepGEMM,
Right.
it really highlights this growing trend of collaboration and knowledge sharing
Yeah.
within the AI community.
Seems like everybody's sharing their cool new toys these days.
Right. Well, by making this technology freely available, DeepSeek-AI is really fostering this environment of collective advancement.
Right, so everybody benefits.
Exactly.
Yeah, I mean, and those performance numbers that we were talking about earlier really showcase what DeepGEMM can do.
Yeah, they do.
I mean, the speedups are remarkable, especially when you consider how complex some of those calculations are.
Yeah, and it really speaks to the robustness and versatility of their design, that they've achieved these speedups across such a diverse range of GM shapes,
Right.
including the ones used in those highly complex MOE models.
Okay, those are crazy.
Yeah.
What I think is even more intriguing is that they managed to achieve this level of performance
Right.
with these surprisingly concise code base.
Mm-hmm.
Like, it's almost counterintuitive that such a powerful tool can be so elegantly simple.
Yeah, that's the beauty of it. DeepGM really demonstrates that power and complexity don't always have to go hand in hand.
Gotcha.
They've created this highly efficient and powerful tool, but they've maintained a level of clarity and simplicity that makes it accessible and understandable.
So it really challenges that notion that cutting-edge technology has to be, like, super convoluted and inaccessible.
Right.
Like, to the point where only a select few can really understand and use it.
Exactly. And this accessibility, I think it could be a real game changer for the future of AI development.
I can see that.
It democratizes access to these powerful tools,
Right.
allowing a much broader range of individuals and organizations to contribute to the advancement of AI.
So it's like taking the reins off,
Right.
letting everybody contribute to this.
Exactly. And I think that kind of open and collaborative approach could really accelerate innovation
Yeah.
and lead to breakthroughs that we can't even imagine right now.
Yeah, that's the exciting part.
It really is.
So it's pretty clear that DeepGEMM is a game changer in the world of AI computation.
Oh, yeah.
It's not just about the speed. It's about empowering a new generation of AI innovators and researchers.
Exactly. And with that empowerment comes a responsibility
Right.
to make sure that we're using these advancements ethically.
Right, for the betterment of humanity.
Exactly.
I mean, as AI becomes more and more pervasive in our lives, we really need to be having these open and honest conversations about its potential impact.
Absolutely.
both the positive and the negative.
Yeah, it's a collective responsibility to make
Mm-hmm.
sure that AI is developed and used in a way that benefits all of humanity.
And not just a select few.
Right. And it's a reminder, I think, that technological advancement should always be coupled with, some thoughtful consideration of their broader societal impact.
Right.
It's not just about what's possible.
Yeah.
It's also about what's responsible and ethical.
Well said. I think that's a really important point to keep in mind.
Yeah, as we continue to explore the world of AI,
Mm-hmm.
it's crucial to maintain that balance between innovation and responsibility.
Yeah, I think that's a good place to stop for now.
Okay.
It's really fascinating to think about the implications of this whole shift toward more accessible AI.
Yeah.
Like, what doors could this open up
Mhm.
for researchers and developers who maybe didn't have the resources to work with these kinds of tools before?
I think it's really about unlocking potential.
Mm-hmm.
Imagine a world where brilliant minds from all over the place
Yeah,
can contribute to solving these huge problems
right.
using AI.
Yeah,
I mean, this is the kind of future that DeepGEMM could help us build.
that's pretty exciting to think about.
It is.
But like we said before, with this kind of power comes a lot of responsibility.
Right.
We have to be mindful of the ethical considerations
Yeah.
and make sure that these tools are used for good.
Absolutely. As AI becomes more and more a part of our everyday lives,
Mm-hmm.
we really need to have these open and honest conversations about its potential impact, both
Yeah.
the good and the bad.
The good and the bad. Yeah.
It's on all of us,
Correct.
to make sure that AI is developed and used in a way that benefits everyone.
Right. It's not just a tool for the privileged few.
Exactly.
It should be something that can actually help improve the lives of everyone on the planet.
Yeah, and I think it's important to remember that
Mm-hmm.
these technological advancements,
Yeah.
they should always be paired with really careful consideration of,
Yeah.
their impact on society as a whole.
Right. We can't just focus on what's possible. We also have to think about what's responsible and ethical.
Well said.
So I think this deep dive into DeepGEMM has been incredibly insightful.
Yeah, it's been great.
It's really shown us that the future of AI isn't just about speed.
Right.
It's also about accessibility,
Mm-hmm.
collaboration, and ethical development.
Exactly. It's a really dynamic and rapidly evolving field.
Yeah.
And tools like DeepGEMM are really leading the way
Paving the path.
to a future where AI can reach its full potential.
It's been a pleasure chatting with you about this.
Like,
I think our listeners are really going to enjoy this deep dive.
I hope so.